Hello, listeners, and welcome to Privacy Chats with Rachel and John. This is a podcast for privacy professionals and enthusiasts alike. I'm John.
And I'm Rachel. Today, we're talking about one of the most perplexing computing systems known to man, which is the human brain. The human brain is really as mysterious to me as the deep sea or the universe beyond the Milky Way galaxy.
Yeah, agreed. The human brain is certainly a mystery to me also. I guess it's one of those things we just take it for granted. It's still up there working on top of our shoulders. I think it's funny that you call the brain a computing system, because really, if you go back to the reason that we invented computers in the first place was that we wanted something that was going to do things that we couldn't do as easily, like complex calculations and stuff like that.
Yeah, at least most of us. Because fun fact, the word computer actually comes from the title that we gave people who were essentially functioning human calculators in their math skills. People that could perform all the complex functions in just like a matter of seconds and probably won game shows because of it and stuff. That's where the word computer came from.
I had heard of that before. I remember that from the movie Hidden Figures.
Yeah.
There was a movie about the original women from back in I think the 60s, maybe 50s or 60s, who figured out the complex calculations at the very beginnings of the space age of how to get people and crafts and stuff into space. They were called computers because of the calculations that they were doing. That was a minute ago, and we've come a long way since then, to the point that I think that these algorithms are inseparable from everything that we do, and like the advances are huge.
Mm-hmm. Absolutely. There's a full circle effect to me too here, where you're citing the 1960s. It's really what I have read and view as kind of the genesis of what we now call artificial intelligence. And all of that was in the endeavor to, like you said it earlier, replicate activities that really humans innately perform in frameworks that we've built for ourselves, based on our own organic intelligence to these other systems.
Yeah, and I think like the name itself suggests the most common AI applications have something to do with a knowledge representation, decision making, perception of a physical reality, language processing. It's all artificial implementations of human intelligence.
Yeah, it's a a continuing cycle where we use our mental frameworks to influence artificial intelligence. They do the jobs that are, frankly, better and faster with processing and just memory and recall than we are. And it gives us capabilities that we wouldn't have on our own.
Yeah, agreed. So, but like there's a lot of research has been happening, and I think things have expedited from the advancements made in storage and computational capacity and stuff like that.
Yeah, definitely kind of like adjacent problems being solved that continue to make the computer versions of kind of what I'll call us in the artificial intelligence space better. But hang with me on the human element. I want to talk about that for a second.
Okay.
All these major breakthroughs in AI, we'll call them like computing problems, were really made possible because they do resemble how the human brains think, not procedurally, A plus B equals C all the time, which in a way computers are a lot better at doing, working in kind of a binary fashion. But instead, we've built models to reflect the fact that we unconsciously think about things and prioritize them in terms of weights for different data points that we've maybe encountered from the experiences we collect and the lessons we kind of teach ourselves inherently. And it just, this circular relationship kind of reminds me of this meme that's really popular on the internet right now, which is that we've taught rocks how to think.
Okay, yeah, I like that. We've taught rocks
with AI, I like
it. I sure, yeah. I like it. In some ways, I think the whole thing it's a combination of what humans can do with their brains and the capabilities of computing platforms. We're trying to kind of merge the two of those things together.
Mm-hmm.
But this is privacy chats, so we're generally focused on privacy. I feel like we're off track. Like this might be a good discussion in a TED talk from, I don't know, 10 years ago or so. Let's tie this into privacy to stay true to ourselves.
Yeah. Now this whole thinking about AI and this framing I'm sharing was really something that I was excited about and thought about more once I started reading some of the advancements that have been made in the neuroscience space. Um,
Okay.
Essentially, thanks to advancements in AI, we've come significantly closer to being able to encode and model human brain activity, um, which, in my opinion, the human brain, again, it's just about that final frontier when it comes to hypothetical sources of personal data, right? Everything's kind of a reflection of that at this moment, but we're not really at the source, really
Yeah.
seeing the inside of the brain.
I get it. So yeah, I'm 1,000%. I'm fully on board with you there. And I think this is somewhat similar to an episode that we had a few episodes ago. I don't fully keep track of them.
There's been a lot now.
But I know, which is great. But we did one about AI being able to identify when you're telling the truth. And I think I mentioned in that the capability was essentially looking into your thoughts. And I forget what the criteria were, like facial recognition and stuff like that.
Mhm.
This is similar. So I get how where you're going with this totally connects back to privacy. So yeah,
Yeah,
let's keep
definitely. And I'm going to take a pause. I got to open the door because my cat's getting mad at me now.
going. Okay. I'm assuming
Can
maybe
only
you left
please
it
so many
out.
animals in this house at once, I guess.
I was gonna say you could edit it out, but it's okay. It's just
I
a
know.
chat.
I know. But yeah, 1,000%. I mean, our minds are still involved in everything that ends up generating the behavioral data aspect of personal
Yeah.
data. But if we had actual mind reading machines, like we would introduce a whole new universe of privacy problems from that, I think.
Well, it could. Really depends on what the data is being used for. I guess who's using it and what control you have. Like if it's my brain and it's my thoughts, I want to have control over that. So it could pose privacy problems for sure.
Yeah, very nuanced, absolutely. And I want to revisit the research I was reading in what's
Okay.
possible with this current state of what's being coined as neuroprivacy.
Okay.
Um, so there's a handful of experiments out there which prove that EEGs, I won't try to attempt the full name, but that's, you can think of the little cap with all the little sticky
Yeah.
nodes like covering your head with the little wires,
Yeah.
as well as fMRI machines, those big like CAT scan looking type machines where your body's stuck in there. Um, they're with given the help of machine learning, we can use those machines to help decode or read either those electrical signals going on in the case
Yeah.
of EEGs, or the energy expenditure taking place within certain regions of the brain, and then use that to encode or represent those signals in the forms of words or pictures, to represent human thoughts. I'll link for anyone that's curious these papers in the description. And I just think that's really cool from a scientific perspective, first of all. But like I said earlier, putting my privacy hat on, it prompted me to think about the use cases, both good and maybe a little bit scary, if those human rights are left unchecked and
Yeah.
unaccounted for. Um, some of the examples I thought of were like using this as a new lie detector, or figuring out how effective an advertising campaign was in more of a commercial setting, or as an employer, like figuring out, it's a little dark, but how much and how well you're paying attention in your workday to I guess, figure out your productivity level.
Yeah, well, yeah, that goes back to another episode too.
Yep.
So yeah, I mean, I guess I wonder about the capabilities and how quickly they're going to develop and advance. And I'm assuming it's going to be fast because of just the pace of everything. But right now, my suspicion is that it can read your brain waves and know that you're looking at a color blue instead of a color red or something like that because a different part of your brain lights up. But I don't know. I'm assuming it can't understand more complex things, but I
Mhm.
don't know. It sounds like we're definitely pushing the envelope from a research perspective, but this does seem pretty niche so far. Research and development is the first step to rolling out new products in the market. So I guess who knows where it's going to go in the coming decades.
Mhm.
I could see this being used to solve problems that are difficult to solve. Um, uh, there's just going to be work to be done. We've talked about in a recent episode about some aging, like people elderly people and some of the disorders they have. So Alzheimer's, dementia, and stuff like that.
Mhm.
So certainly any research that's reading the brains of people, I hope that it would help with those kinds of things. So
Oh,
what kind of stuff is on the market that actually helps to solve problems through monitoring brain activity?
yeah. No, I like your call out about, you know, helping folks with ailments like Alzheimer's, dementia.
Yeah.
Like there's definitely a lot that we could use for this for good. And I think that's generally it seems where the consumer applications are going right now.
Okay.
And again, these aren't quite to the advancement of the breakthrough that I was just sharing with actually representing human thoughts with the help of machine learning and better representations and frankly quicker representations of brain activity. They're a little bit further removed. So one example are these headbands I've read that can monitor your state of relaxation
Okay.
to help you get into a better meditative state.
Yeah.
Or there's also these hats or headsets of sorts that can help measure fatigue to reduce workplace accidents in say situations that are highly exhausting or very manual, which I
Okay.
think are both pretty great. I haven't double clicked into where to get them, the details, who has them, and whatever. But through that research, I thought it was this amazing statistic showed up. This article suggests that the neurotech, so these type of devices, the market behind that is growing at a compound rate and is expected to reach 21 billion by 2026. So just a little
Wow.
over a year from now.
Yeah, that's
Um,
huge.
of course. And, there's a lot to go. It looks like in terms of our understanding the brain and also the software required to support all of that data being processed. And especially if you want to make it non-invasive, like all that has to go over Wi-Fi. So we're still pushing the bounds of both, neurobiology and then technology itself. But I can't say with all the investment being put into it with this market cap, like who knows how far off exactly we are.
Yeah, agreed. The but isn't this where AI could come into play?
Yes, I think it can help, just like in the case of the research I had shared earlier, where the fact that there are better models to quickly pull up representations in the form of text, in the form of images,
Yeah.
through that as long as there's enough data and there's mechanisms to process and represent it, that's where AI is going to help out a lot here. And I'm
Okay.
using a very blanket representation of AI when I say that, very nuanced. But again, as long as we can manage that influx of data, there are a lot of possibilities out there. For example, Neuralink, Elon Musk's little brain implant toy right now,
Yeah.
it generates 200 times more brain data per second than can be transmitted wirelessly. So to actually make it not funky and weird from a consumer standpoint, you have to get over that barrier. But again, the investment put into it, who knows how far we are away from it until it happens. At least I don't. Maybe people out
Yeah.
there closer to it.
Yeah, I get that. So, and it's interesting to look at it from that perspective because we think of technology being so advanced and the computational power and the amount of data that we can transmit and stuff like that. But when you look at these numbers, it really does indicate how much more powerful the human brain is than
Give
maybe
it
we
credit
give it
for,
credit
I
for.
think.
Right, exactly. So, hey, kudos, brain.
Yeah.
So, it's no wonder that we get headaches or fatigue when we think too much or work too hard.
Yeah, seriously, I'm with you. And there's still other ways that technology can be improved in theory to get closer to measuring emotions in less invasive ways. Maybe it doesn't have to involve the brain at all, right? Like
Right.
physiological changes in your body, like muscle twitches, heart rate, even thermal monitoring, how hot certain parts of your body get in response to what stimuli, the amount of sweat you produce. Like there's a lot of other signals that could be used to profile your current state and at least read what we can attribute as going on inside your head.
Yeah, I get that, but there's a lot involved with that. I mean, today with the technology today would even if it exists
Hmm.
would require a great deal more equipment in combination with each other to support. So I don't see that happening right away. We're not going to go
Yeah.
out and buy fMRI machines in our homes to
For
help
only
us with, right?
yeah.
Exactly.
Yeah. And I think I'm sure most of us have now seen more nuanced examples of the type of monitoring technology I'm talking about. I mean,
Yeah.
facial expression, facial
Yeah.
recognition, eye motion monitoring. A lot of them are used in, biometrics and whatnot, and they have been for a while. So it's nothing net new, but the degrees of accuracy really depend on the outcome that you're trying to achieve from it, right? To infer what's going on exactly in your head based on a simple facial expression depends on a lot more than just that blanket state. It's not a very clean taxonomy in my opinion.
Right. But it's not necessarily impossible today.
Yeah, it's not. It's more, something that I guess definitive about your interactions with the world should have a really high bar for as far as accuracy if
Yes.
it's going to go and make assessments. And through
Agreed.
this conversation is reminding me of a chapter specifically titled "Affect" in this book called Atlas of AI by Kim Crawford.
Hmm.
So she dedicates a whole chapter to describing the state of technology that we're talking about, with affect in really that's just our emotional state, our representation of our mood or feeling at a given point.
Okay.
She dedicates a whole chapter for this and covers a lot of startup and research efforts dedicated over the last 40 years or so to this technology. A lot of it's focused on facial recognition technology.
Okay.
But the conclusion was we really haven't figured out how to universally and with that high degree of accuracy detect effect reliably from facial technologies alone, at least, even
Mhm.
with the help of AI. There's just, it's really the relationship between the drivers of your emotional response to a given stimuli, like still have a degree of, uh, translation that isn't transparent to us yet. Like we're talking about the brain as kind of a black box. Um, it's really just a side effect of what's going on in our brain, but there are
Yeah.
cultural implications to that, and it's not a universal taxonomy. I'll go back to saying that, which I think was kind of surprising when I read it in the level of detail that she describes in that book. It's a great read for anyone interested.
Yeah, that I thanks for calling that out. I wasn't familiar with that book until you brought it up for this chat. So I have it in my Amazon cart now, so I'm looking
Cool.
forward to reading it. And some of the stuff, like I wasn't aware of some of what you're talking about. Some of it I think that I did. Like for example, I read a research study that was, and I forget the details of it, but they were essentially had figured out a way to measure blood pressure with just cameras. So just by facing a camera towards a person,
Oh, good Lord.
the earlier stages of being able to identify what people's blood pressure is.
Yeah.
So the possibilities are there, and so let's hypothetically say that one of mentioned Elon Musk earlier, that one of these tech billionaires cracks the code for decoding the brain via some sort of a wearable device. Um, what are you picturing here? Some sort of a
Little goofy like head
helmet?
or helmet. Yeah, no,
Yeah.
when we're talking about brain reading machines, I keep picturing the chum bucket helmet in the SpongeBob SquarePants movie. I think my Gen
Yeah.
Z is showing now, but
Okay. Yes, I remember that, but more when my kids were watching, I guess. Um, but so some of that, it seems to be getting very close to I'm not sure if you're familiar with the movie Minority Report,
vaguely.
with Tom Cruise, that it essentially predicted who would commit crimes. And I remember there's some wearable stuff in it, it was pretty far-fetched.
Yeah.
And then they sentenced them proactively. So, but anyway, let's get back on track. Could data from a helmet like this be something that is admissible in court, for example? Like if we're actually using it for real things.
Yeah, I was curious about that too, and it looks like, again, not a lawyer, but at the
Yeah.
moment, legal systems in most developed countries, as far as I've read, don't accept neuro data as evidence in court. And I assumed when I read that it was because of clearly the ethical issues related to this, and I think it's still, that's still part of it. But it's
Yeah.
also related to the fact that like the data for it is not really reliable. Going back to what I'm talking
Right.
about, there's not a universal really taxonomy to digest like effect, and especially when you're talking about um evidence for a case determining whether someone did or didn't do something, that is even further advanced than effect. You're talking about something like memory recall, and like the clarity of that and the reliability of that has to be really high. And it's also, yeah, I also thought about the fact that like even to your point earlier with, I don't think we're going to have fMRI and EEG machines just lying
Yeah.
around, like to to get someone's data for that, they have to be willing and or participating subjects, so to use that to try to, test in a court of law, I don't know if in all cases that would really organically happen.
Yeah, and because of the importance of it, I would hope that there's a really high bar for the stuff being admissible in court.
Yeah.
And to that point, like I wonder what the standard is like here in the US for stuff like that, and how it compares to other developed countries, because we often, for some reason, end up comparing the US to the European Union.
Yeah.
But yeah, what are the standards and how do we stack up?
Yeah, I agree. I mean, I've learned about something called the Daubert standard, which
Okay.
is a legal framework that sets the bar for what's considered admissible in court in cases involving neuroimaging data. So there's a little bit of nuance there between what we're like calling neuro data. I think there's, some confusion in the buckets, but essentially it designates the court judge as a gatekeeper that determines if any given piece of evidence, frankly, brought up by an expert witness. So that would be, a scientist or someone in the neuroscience and technology space, probably
Yeah.
helping bring that evidence to court. Whether that was done in legit scientific ways and use truly scientific knowledge.
Yeah, so just to respond to that, the fact that there is a standard for measuring the reliability of neuroimaging data in courts, like
Mhm.
that, just the fact that that exists indicates to me that things are farther along than I would have expected. But how do you test something like this scientific legitimacy of something in court? Because science is, well, I'll stop there. But
Yeah, I
how do
think
you
it's a
test
contentious
that?
debate today. I think if you just go out in the world and say what's scientific and not, like you're going to get
Yeah,
a lot of
right,
different, unfortunately, conflicting answers. But
right.
it's it has a combination. Again, I kind of called it a framework. I mean, it is a standard, but there are guidelines under these things that test different aspects of what the legal system here in the U.S. has collectively determined as scientific.
Okay.
But it essentially involves assessing the data for whether it's relevant to the case, whether it's reliable, repeatable, and that the logic is of sound scientific methodology. So that involves creating a hypothesis, testing that hypothesis, figuring out whether there is an error and what that error rate is, and so on. So a lot of qualities that while I was reading it, I'm like, oh, it's kind of like the judge, the judge guidelines on a clipboard at a school
Yeah.
fair, honestly. Like it's
Yeah.
really same or similar principles.
Well, it's the scientific method. It's tried and true. And
Yeah.
yes, it's applied in, the school science fairs and stuff like that, but it's also applied in real
Real life.
important science stuff. Yeah. Um, so, but in these cases, like in court, the stakes are much higher than, winning a science fair
Yeah.
because of, so when you're relying on that and measuring brain data, it's a whole different, it brings it to a different level.
Yeah, yeah. And based on the research, it sounds like the Daubert standard has like only really been around for maybe the last 100 years or so. I'm estimating, but it has successfully debunked like pseudoscience and junk science that has been brought into court. So it's achieving
Okay.
something. Now, in the neurotech space, though, I like that you're thinking about like, okay, it's a little bit more than impossible now. It's a little more on the side of possible than we thought. But still, like the neurotechnology that we somewhat opened the episode with, like using, AI to actually help represent what's going on in the brain.
Yeah.
Generally, in cases that have been broader, it's been entertained in more of the academic space. Like we haven't met that collective bar for creating precise enough and reproducible results for
Okay.
neurotech. So it usually won't make it in that, like past the Daubert standard.
Okay. Usually won't. Is that
Yeah, it's
is
not
that good?
definitive.
Is that
Okay.
good? What do you mean?
I'm glad you asked because I've been hedging for a bit here on that.
Okay.
There is something called brain fingerprinting, which is essentially like a super effective lie detection technique.
Okay.
It resembles the traditional polygraph in the sense that it will measure the corresponding physiological responses to a person has to a given event. So really in the sense of an investigation, it could be used when a subject is, say, shown representations of the memory that an investigator is looking for them to recall to kind of prove whether they were maybe involved in a particular incident or not, and then therefore prove innocence or guilt. And if there is a relevant memory to that subject, then there's the surge of electrical activity. I think they use like the same EEG little electrodes that we were talking about at the beginning of the episode to
Yeah.
discern this. So the accuracy is still even highly debated and under speculation, but it has in a very small, I want to say numbers. There was one case that I read about this that
Okay.
it was used successfully, but the impact of getting it wrong is huge. So it's been highly contentious in the last 10 years or so.
Yeah, I get that, and I'm skeptical. You can probably see that in my expression. And I've talked about liking some like crime podcasts and stuff like that. And some of my
Yeah.
favorite crime podcasters say like you can't trust lie detectors and people shouldn't take them when the police ask you to and stuff like that.
Yeah.
So it's a lot to trust. There's a lot of big claims to be made here, but what you're describing there about this
Brain
brain
fingerprinting.
fingerprinting, how is that different from neurotech? What's the Venn diagram there for those?
Yeah, they're somewhere in terms of what they're like, in a broader bucket, assessing, or what, and also the use case they're being created for in this hypothetical sense of figuring out if someone did or did not do a crime. Um, but what distinguishes the brain fingerprinting method, that kind of measuring of electrical waves in response to a given perhaps memory or not memory,
Okay.
is that it's not really revealing that brain metadata. It's taking one element, one response, so electrical signals used in memory
Yeah.
retrieval, associated with memory retrieval,
Yeah.
but it doesn't give you anything valuable characteristically about that memory. It just shows you, okay, yes, there was a change in electricity at this given point in time that we
Yeah.
happen to show this person this image that could trigger a memory of an event.
Yeah, I see that, but it's like, and I can see the potential in the future, and I'm even thinking of like some Star Trek episodes and stuff. But I'm not gonna draw you down that path with me. But it sounds like the breadth of these use cases from what you're describing is very limited overall right now.
Yeah, it is. Until we like have a way to collectively, accept the more emerging technologies too, and the method
Yeah.
behind that, and it becomes collectively indisputably accurate. There's a lot of words here. With something as difficult as capturing your exact thoughts and emotions. I don't hope to see this again in any cases, and I think it'll continue to be challenged until we get there, but still worth discussing,
Yeah.
right?
Oh yeah, it's really interesting to think about the possibilities. I would say that this belongs in the space of this is interesting science, and I think it's got a huge potential benefit for the future. But I wouldn't call it more than a half-baked concept at this point, and I'm surprised courts are even entertaining it.
Yeah.
But we mentioned before that new technologies, and that's what we're talking about here, is new technology. They often gain traction when there's ways identified to make money from them.
Mhm.
That's the driver for everything, right? So I suppose there could be a future use case where, for example, advertising could leverage this. But it also seems like that's a lot of work and a lot of expense to go through for something that you could do a lot easier and a lot cheaper.
Yeah, I totally agree. I mean, there's a lot of methods we were talking about in the more legal sense of like,
Yeah,
lie detectors are taking a signal that could represent your response. I mean, it's not 100% effective, but if you want to go over, a majority of level of effectiveness, like facial expressions, may not be all that ineffective in assessing
yeah,
a response to an advertisement. And for that, since it's not, I mean, there are definitely ethical concerns with that could fill up a whole other episode.
yeah.
But you're still, that's the whole conversation about AI being used in decision making over large quantities of personal data, your effect being used based on your behavior. And that's really that's the genesis of most of the ethical conversations around using personal data anyway. It doesn't have to
Yeah.
necessarily be brain derived. It can be representations of it, your behavior.
Yeah, agreed. And the fact that like we often talk about the fact that regulation and oversight and ethics and all of that seems to lag. So like the technology companies out there and they'll develop things, and then all of a sudden regulators figure out, oh my goodness, we need to regulate that. So
Mhm.
maybe what our public service announcement is. We're putting it out there that this thing is coming, and the industry of regulators and ethicists and privacy professionals need to be ahead of that, because it's coming, and
Yeah.
we know it is. Also, as we were talking, and I don't want to go too far down this rabbit hole, I just kind of want to tee something up here. If it's possible for you to measure a brainwave and understand what a person is thinking by measuring that brainwave, is it possible to like reverse the stream or change that in such a way that now, instead of reading the brainwave, it can stimulate the same brainwave and essentially influence what people think by manipulating their own brain activity? So
Yeah, that's that is something out of Black Mirror episode and more. I mean, we we
there
reach
you
that
go.
point in every episode, it seems.
We do,
Um,
yeah.
that deserves its own episode, like hypothetically. And I
Maybe.
think, again, I don't think you're far off in kind of the stream of logic of, if we can do even a little bit that can get us closer there, why not push those frontiers more on a, in a scientific sense, but then also, who knows, a commercial and law enforcement sense. Like it has to
Yeah.
be part of that natural trajectory. So
Well,
maybe
let's
not
keep
as
talking
near
about
to
the
us,
all right.
but
Let's keep talking about the Black Mirror episodes, and maybe eventually they'll reach out to us and say, "Okay, come and write an episode for us."
finally. Okay, you've given us enough juice. Oh my God. Yeah, I love it. But TLDR, let's encourage the thinking and the kind of preparation for these sorts of technologies. Even if it's hypothetical now, it's better than being unprepared and being so responsive that there's
Yeah.
really not good protections around, particularly disastrous outcomes related to these technologies. Am I
Yeah.
right?
Yeah, agreed, for sure. So I think we might, let's wrap this one up. You
Call
want
it
to
a
do
wrap.
the speech for the lawyers that they like to hear?
Oh yeah. Before we go, please know that the information shared throughout this episode is that of our own and not affiliated with our employers or any other organizations. These episodes are produced in our own time and are based on our own research and very much our professional opinions.
And yes, agreed. And thanks for teeing this one up, Rachel. This topic was your idea, and you did all of the research on it, so I appreciate that. Thanks for everyone who's listening, and see you next time.
Absolutely. It was a fun one. Bye, everyone.
Yeah, see you.